Preparing for a technical interviews at Capgemini interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain the 4 pillars of object-oriented programming with practical examples? The 4 pillars are encapsulation, abstraction, inheritance, and polymorphism. Encapsulation keeps data and behavior together while controlling access through methods. Abstraction exposes only essential operations, such as a payment interface. Inheritance allows a specialized class to reuse common behavior, although composition is often safer. Polymorphism lets different payment implementations respond to the same method call. Together, these principles reduce duplication and make systems easier to extend and test. While answering, define encapsulation, abstraction, inheritance, and polymorphism. Connect each to maintainability, reuse, security, and extensibility. Include a simple example from a business application. Question 2. What is the difference between an interface and an abstract class, and when would you choose each? An interface primarily defines a contract, while an abstract class can provide shared state and implementation. I choose an interface when unrelated classes should support the same capability, such as payable. I choose an abstract class when closely related classes share validation, fields, or template behavior. Modern languages may allow default interface methods, but I still avoid putting excessive logic there. The decision should support loose coupling and future extension. Make sure to cover contracts versus shared implementation, multiple inheritance constraints, state management, default methods, testability, and examples showing when an interface or abstract class provides better design. Question 3. How would you find duplicate elements in an array, and what are the time and space complexities? For an unsorted array, I would scan once with a hash set. If an element is already present, I record it as a duplicate. Otherwise, I insert it. This gives average O(n), time and O(n) additional space. If extra memory is restricted, I can sort the array first and compare adjacent values, producing O(n) log n, time and potentially modifying the input. I would clarify whether duplicate values should be returned once or repeatedly. In your answer, explain a hash set solution, sorting alternative, duplicate reporting requirements, input constraints, complexity analysis, and how the solution changes when memory is limited. Question 4. How would you optimize a slow SQL query in a production application? I would first reproduce the issue and inspect the execution plan rather than guessing. I would check for full table scans, inefficient joins, missing or unused indexes, unnecessary columns, and expensive sorting. Composite indexes should match common filtering and ordering patterns, but I would avoid indexing every field because writes become slower. I would also review pagination, query parameters, and data volume. Finally, I would benchmark before and after changes using production-like workloads. Be sure to mention execution plans, indexing, selective filtering, joins, returned columns, statistics, parameterization, pagination, monitoring, and validating improvements with realistic production-like data. Question 5. What is the difference between a process and a thread, and when would multithreading help? A process has its own memory space, while threads share memory within a process. Processes provide stronger isolation but require heavier communication. Threads are lighter and useful for concurrent I/O, such as handling multiple requests. For CPU-bound work, benefits depend on the language runtime and available cores. Shared state introduces races, so I use immutable data, controlled synchronization, or thread-safe collections. In production, bounded thread pools prevent uncontrolled resource consumption. Focus on memory isolation, scheduling, communication cost, synchronization, CPU-bound versus I/O-bound workloads, race conditions, and practical safeguards such as locks, immutability, or thread pools. Question 6. How would you design a REST API for managing customer orders? I would model orders as resources. get orders, post orders, get orders, id, and patch for permitted state changes. Post would validate items and return 201 with the created resource. Missing orders would return 404, and invalid input 400. I would add authentication, authorization, pagination, consistent error bodies, and an ID impotency key for safe retries. Order transitions should follow explicit rules, such as preventing a shipped order from returning to pending. In your answer, cover resource-oriented URLs, HTTP methods and status codes, validation, pagination, authentication, ID impotency, error formats, versioning, and consistency across order state transitions. Question 7. Explain the difference between authentication and authorization in an enterprise application. Authentication answers, who are you? Authorization answers, what are you allowed to do? A user may authenticate through a corporate identity provider and receive a token, but authorization determines whether that user can approve refunds. I would enforce least privilege using roles or fine-grained permissions, validate token signatures and expiration, and check access on every protected operation. I would also audit sensitive actions and never rely on client-side controls alone. Make sure to distinguish identity verification from permission checks. Discuss sessions, tokens, roles, least privilege, token expiration, service-to-service access, and protecting sensitive operations. Question 8. What is database normalization, and when might denormalization be justified? Normalization organizes data to reduce duplication and prevent insert, update, and delete anomalies. For example, customer details should not be repeated in every order row. I would usually normalize transactional schemas for consistency. Denormalization can be justified for read-heavy dashboards, reporting, or carefully designed aggregates where repeated joins are expensive. However, it introduces synchronization risk, so I would define update ownership, use reliable refresh mechanisms, and confirm the benefit through query and workload measurements. Discuss reducing redundancy and update anomalies through normal forms, then explain read performance, reporting, caching, consistency risks, and measuring workload patterns before denormalizing. Question 9. How do you handle exceptions properly in a Java or similar backend application? I use exceptions for exceptional conditions, not normal branching. I create meaningful domain exceptions, translate low-level failures at service boundaries, and handle responses centrally so APIs remain consistent. Logs should include correlation identifiers and useful context without exposing secrets. Resources must be closed with language-supported cleanup constructs. I avoid catching overly broad exceptions or silently ignoring failures. The goal is graceful recovery where possible, clear diagnostics, and safe messages for clients. Be sure to cover checked versus unchecked exceptions where relevant, meaningful custom exceptions, centralized handling, logging context, user-safe responses, cleanup, and avoiding swallowed or overly broad catches. Question 10. What is the difference between unit testing, integration testing, and end-to-end testing? Unit tests verify a small component in isolation and run quickly, usually with mocks or simple fakes. Integration tests verify collaboration with real dependencies such as a database or message broker. End-to-end tests exercise the complete user workflow and provide high confidence, but they are slower and more fragile. I use many focused unit tests, targeted integration coverage for boundaries, and a smaller set of critical end-to-end scenarios. This balance supports fast, reliable feedback. In your answer, compare scope, speed, isolation, confidence, maintenance cost, test doubles, database integration, and the appropriate testing balance for enterprise software delivery. Question 11. How would you investigate a production application that suddenly became slow? I would first confirm the scope, affected endpoints, users, regions, and start time. Then I would compare latency, error rates, throughput, CPU, memory, and database metrics with the baseline. Distributed traces can reveal whether the delay is internal or dependency related. I would check recent deployments, configuration changes, traffic spikes, and slow queries. If a change is strongly correlated, I would roll it back or mitigate safely, then document the root cause and prevention. Focus on defining the symptom, checking recent changes, metrics, logs, traces, dependency health, database performance, resource saturation, rollback decisions, and communicating impact during incident response. Question 12. What is a microservice, and what challenges does it introduce compared with a monolith? A microservice is a relatively independent service aligned with a business capability and deployable separately. It can improve team ownership, scaling flexibility, and release independence. The cost is substantial: network failures, distributed tracing, contract management, deployment automation, and cross-service data consistency. I would not split a system by technical layers alone. For a small product or inexperienced team, a modular monolith may provide clear boundaries with much lower operational complexity. Mention independent deployment, bounded contexts, ownership, network communication, data consistency, observability, deployment complexity, failure handling, and when a modular monolith may be more appropriate. Question 13. How does a hash map work internally, and what causes collisions? A hash map computes a hash from a key and maps it to a bucket. If multiple keys select the same bucket, the implementation resolves collisions using chained entries or a tree-like structure. Lookup is average O(1), assuming a good distribution, but can degrade with many collisions. When the load factor crosses a threshold, the table resizes. Keys must obey consistent equality and hashing rules. Mutable key fields are dangerous because retrieval can fail after mutation. Explain hashing keys into buckets, collision handling, equality checks, load factor, resizing, average versus worst case complexity, and requirements for consistent hash code and equals implementations. Question 14. How would you implement a binary search, and what assumptions must hold? Binary search requires the array to be sorted. I maintain low and high boundaries, calculate a safe midpoint, and compare the target with the middle value. If the target is larger, I discard the left half; otherwise, I discard the right half. The process takes O log n time and O(1) space iteratively. I would specify whether to return any match or the first occurrence, then test empty, singleton, duplicate, and missing value cases. Cover sorted input, boundary handling, midpoint calculation, loop invariants, duplicate behavior, logarithmic complexity, and testing empty arrays, one-element arrays, and absent targets. Question 15. What are the key principles of Agile development, and how do they affect your engineering work? Agile emphasizes delivering valuable software iteratively, collaborating closely with stakeholders, and adapting when requirements change. In practice, I break work into small, testable increments, clarify acceptance criteria, and integrate code frequently. Reviews and demonstrations expose misunderstandings early, while retrospectives help improve the process. Agile does not mean skipping design or testing. Automated quality checks, maintainable code, and technical debt visibility are essential for sustainable delivery across releases. Make sure to discuss iterative delivery, customer feedback, working software, collaboration, changing requirements, backlog refinement, continuous integration, retrospectives, and maintaining quality during speed-focused delivery. Question 16. How would you secure sensitive customer data in an application? I would classify data first and collect only what the business needs. Sensitive information should use TLS in transit and strong encryption at rest, with keys managed separately from application code. Access should follow least privilege, with secrets stored in a dedicated vault and rotated regularly. I would mask sensitive fields in logs, validate inputs, audit access, protect backups, and define retention and deletion policies. Security controls should be tested continuously, not added only before release. Discuss data classification, encryption in transit and at rest, secrets management, access control, masking, input validation, audit logs, retention, backups, and avoiding sensitive data in logs. Question 17. What is continuous integration, and how would you build a reliable CI/CD pipeline? Continuous integration means merging small changes frequently and validating them automatically. My pipeline would compile the application, run unit and integration tests, perform static analysis and dependency checks, package a versioned artifact, and publish build results. Deployment would promote the same artifact through environments, using configuration outside the package. I would add approvals where risk requires them, health checks, monitoring, and an automated rollback strategy. Pipeline credentials should be short-lived and protected. In your answer, cover source control practices, automated builds, unit and integration tests, static analysis, artifact versioning, environment promotion, approvals, rollback, observability, and secure pipeline credentials. Question 18. How would you design a resilient service that depends on an unreliable external API? I would set strict connection and response timeouts so one dependency cannot exhaust resources. Retries should be limited, use exponential backoff with jitter, and apply only to transient, idempotent failures. A circuit breaker can stop calls during an outage, while bulkheads isolate affected workloads. Depending on business needs, I might serve cached data or queue work for later. Metrics should track latency, failure types, retry volume, and circuit state so operators can respond quickly. Focus on timeouts, retries with exponential backoff, jitter, circuit breakers, bulkheads, fallback behavior, idempotency, rate limits, observability, and avoiding retry storms or unacceptable stale data. Question 19. Describe a time you received conflicting technical requirements and how you resolved them. When requirements conflict, I first restate the underlying business goals and identify which constraints are truly fixed. I ask stakeholders for examples, quantify trade-offs such as cost, latency, delivery time, and risk, then present options rather than arguing from preference. I document the decision and assumptions, obtain agreement from the responsible owner, and deliver a small validation increment when uncertainty is high. This keeps discussion evidence-based and prevents hidden expectations. Be sure to explain clarification, stakeholder alignment, technical and business trade-offs, measurable decision criteria, documentation, incremental delivery, and how you handled disagreement professionally. Question 20. How would you approach a coding problem you have not seen before during the interview? I would restate the problem, clarify inputs, outputs, constraints, and edge cases, then work through a small example. I usually describe a straightforward approach first before identifying its bottleneck and improving it with an appropriate data structure or algorithm. While coding, I explain invariance and complexity, then test empty, minimal, boundary, and adversarial cases. If stuck, I communicate the specific uncertainty and make incremental progress rather than silently guessing. Mention clarifying requirements, examples, constraints, brute force first, optimal strategy, complexity analysis, edge cases, communication, testing, and improving the solution without becoming stuck in silence. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.